Good afternoon, everyone. I'm Amrita from class 9A, and I'm here for today's maths exhibition to present on the topic clinometer. Firstly, let us begin with the basic questions. What is a clinometer? A clinometer is an instrument used for measuring angles of slope, height, elevation or depression of an object with respect to Earth's gravity. What are the uses of clinometer? A clinometer can be used to measure heights of trees, poles, towers, and buildings. You can also use it to measure slopes for preliminary surveying and grade work and site drainage. Clinometers are used in many industries. Some industries include civil engineering projects, geology industry, construction industry, satellite weather monitoring, natural surveying, etc. For today's presentation, I will be taking two illustrations of models related to the construction industry. My first illustration will be to find the inclination of flat planes, roofs, pillars, or beams. And my second illustration will be to find the angle of planes and find the developed length of objects. Let us move on with our models. Beginning with illustration 1, using the clinometer, we can find the angle of elevation of beams under constructions. With the angles, we can see if any construction is faulty or not and rectify any mistakes. Here, the first two beams are at an elevation of 0 degrees. So, any roof to be built on top will be perfectly horizontal and sturdy. But there is an inclination of 30 degrees in the other two beams, meaning the roof will be slanting and even topple. Before we move on with our second illustration, let us see the different types of buildings in our model. We have the Leaning Tower of Giza. We have a building with horizontal and parallel corridors. We have a house with a slanting roof. We have a building with inclined stairways, and we have a kacha house. Here, using a clinometer, we can find the developed height of the Leaning Tower of Giza and the slanting roof. Let us find the developed plane for the slanting roof first. To find the developed height, we first need the vertical height. Here we can see that the vertical height is equal to 7 centimeters. After taking the height, we must take the value of theta, that is the angle of inclination. We can see that the angle of inclination or theta is equal to 60 degrees. According to trigonometry, the cos theta is equal to 0.488 or approximately 0.5, that is 1 by 2. So, to find the developed length, that is L, we take the formula h upon cos theta, that is 7 upon 0.5. So, the final value we get after calculation is 14 centimeter. Let us cross check. Yes, our calculation was correct. It is 14 centimeters. Now, just to confirm if our formula was correct, let us take one more example, the Leaning Tower of Giza. For this example, we'll be finding the inner developed length. So, the height should also be the inner height. Here, the inner height or IH is equal to 20 centimeters. What is the value of theta? Here, theta is equal to 25 degrees. So, as we've done in our previous example, we'll be taking the value of cos theta. And we'll be taking the value of cos theta, which is equal to 0.9. So, the developed length or IL will be equal to IH upon cos theta. That is 20 by 0.9. And the final value we get is 22 centimeters. Let us cross check our calculations. Yes, our calculations were correct. It is 22 centimeters. This proves that the clinometer can enable us to find angles of elevation, angles of depression, and various functions that can be used. Thank you. I hope you enjoyed my presentation. I would be happy to answer any questions if there are.
Good afternoon, Amrita.
Good afternoon, ma'am.
Amrita, you're from class 9, right?
Yes, ma'am.
Can you tell me which concept of mathematics has been used here?
Ma'am, here the concept of trigonometry has been used.
Okay, so that comes in class 10, I guess, right?
Yes, ma'am. Yes, ma'am.
So, do you know all the basic concepts about trigonometry?
Ma'am, I brushed up the basic concepts, but I didn't go in detail.
Okay, fine. Just tell me one thing. What do you understand by angle of depression and angle of elevation?
Very good afternoon to all teachers and judges. My name is Disha Satle. I'm from class 9, Hillwoods School, Gandhinagar. Our project is a circular geoboard. Geoboard is a mathematical manipulative which is used to explore basic concepts of maths and most frequently the concepts of geometry such as perimeters, areas, characteristics of triangles or any other shape or polygon, and it consists of a physical board with a certain number of nails half driven in, around which are the wrapped geobands which are made up of rubber. So let's have a look at our geoboard. This is our geoboard. This geoboard has a center at which we have attached a pro-circular protector in order to measure the angles, and around it are nails driven in a circular manner, and we have named them from letter A to Q in order to make the concept easier to understand. Now, with the help of this geoboard, I'll be explaining three properties of circles on this. So, the very first properties is equal chords of a circle subtend equal angles at the center. So, for this, on this geoboard, we will take two equal chords and then join them with the center and measure if the angles subtended are equal or not. So, let's take chord RQ and chord KL and join them with the center. Here's the chord RQ and here is the chord KL, and I've joined them with the center. Now they subtend the angles at the center, and these angles which are subtended come out to be 20 degrees each, which proves this. Let's move on to the second property. Second property is angle in a semicircle is right angle. So for that I need to divide the circle into two equal parts and an angle in a semicircle. So I'll join this with any of the points. Now if we measure this point would measure as 90 degrees. Why? Because the property goes like angle in a semicircle is right angle. The next property, same. If you are told to find the center of the circle with the help of this circular geoboard, how would you do that? You need a property for that, and the property is equal chords and their perpendiculars meet at the center. So let's take any two chords. I'll take chord DR and here I'll take chord NP. Now if I find their perpendiculars, so their perpendiculars meet at a center. Remember, these chords are non-parallel and their perpendiculars are meeting at a point that is none else but the center of the circles. Geoboards have a lot of benefit in the field of education. The very first benefit is children find it very interesting to find the to explore the concepts of maths, as I said, with the help of this colorful geoboards, and it's an innovative and attractive and a fun-filled way to lay a strong foundation in the field of education for children. At last, I would like to say that we would like to make such toy come devices that would help students to understand the concepts of maths by practically doing it and exploring it, rather than the old methodology of understanding the concept by paper and pen. And we would design more such projects and more such innovative ways in which children would, rather than remembering or memorizing the concepts, they would explore them, they would practically do them, and would lay a strong foundation for them. Thank you.